Good evening. Thank you for inviting me. It's a delight to be here. For the students here, thank you for coming during your midterms. Your minds are probably elsewhere. You're going to be working late tonight. So tonight, as was indicated, I want to sort of give an insight of how I've gotten involved in both the arts and sciences during my career. And I'll walk you through some personal and intellectual context for that. And as Rachel mentioned, I just took up a position at the University of Texas of Dallas, both as a professor of physics and as a professor of art and humanities. And so I'm part of a hybrid breed, and I'm going to explain to you why I find this such an exciting time for this kind of work. So the first question I'm going to try and answer then is, what would motivate someone to move from the south of France to Dallas, Texas? So when I tell people of this move, that's normally the first question I get. The second question I get is, what the hell is an astrophysicist doing in a school of arts and humanities? And so I'm too old for it to be my midlife crisis, but indeed it's allowing me to combine two of the interests in my professional life. As Rachel mentioned, I did my bachelor's degree in physics. I became a specialist in X-ray optics, building X-ray telescopes. Went on to Berkeley, where I was involved in building a large NASA satellite, Extreme Ultraviolet Explorer, which mapped the sky in that electromagnetic band. So I'm a scientist. I'm an instrumentalist. I try and understand the world by building new instruments to see part of the world that we didn't know about before. Of course, as was also mentioned in the introduction, there's also a personal background to this. And that, of course, is my father, Frank Malina, who, as was mentioned, not far from here, and you can see him in the pith hat in the photograph on the left here, did rocket tests in the Arroyo in the mid-1930s, went on with Theodore von Karman to found JPL and Aerojet General Corporation, and had a very successful career as a rocket engineer. At the same time, he worked as a professional artist, and when I was a kid in our home in Paris, it was very confusing. I would come home from school, and my dad was painting. I thought that's what engineers did, because for him it was just a seamless combination of expressing his interest in understanding the world around him. And so indeed I grew up in a household where that kind of hybridity was totally normal, and it wasn't until later that I decided that you had to make choices at every point of your career. The team that my father led went on to build a rocket called the WAC Corporal, which was launched on October 11th, 1945. It's almost an anniversary this week. And was also launched as a second stage to a V2 and actually reached outer space. It was maybe the first human-made object to reach outer space. At that point of his career, my father decided to make a major career move. Malina is a Czech name. My grandparents were Czech immigrants to Texas. And my father decided to move back to Europe to help rebuild Europe. The other part of the story there is, of course, at the time, the US government started trying to put nuclear bombs on rockets, and my father decided that was the last thing he wanted to be working on, and that was not the way to build a safer world after the Second World War. So he moved to Paris, where he was part of the founding team that set up UNESCO, the United Nations Educational, Scientific, and Cultural organization, where he became the director for science before he left, setting up projects in the Hylian Amazon and the Negev Desert, and helping build some of the scientific collaboration that after the Second World War was an instrument for world peace. My father then got wrapped up in the McCarthy hearings at that point, lost his US passport, ended up as a political refugee in Paris, unable to travel, and so he became a full-time artist. He'd been always working as an artist, and he developed in that period what are now called kinetic artworks, paintings that move. This is long before computer chips, and it was really difficult to make paintings that moved. In fact, my father filed patents both in rocketry and in art. And so indeed, he viewed both of his professional careers as integrated things. But beyond that, he really felt that artists had to appropriate science and technology for their own purposes. And I remember, maybe I'm making it up, but I remember the family story. He was taking oil painting classes in Paris at the time. He came home one day and he said, "I'm tired of painting dead fish." And indeed, in his oil painting school, they were painting still lives and so on. He says, "I want to make art about the world I know about, which is science and technology." And so he was interested not only including the scientific landscapes and his own artistic expression, but also using technology in his art making. And he used to joke that in Paris, there is more technology in my kitchen than all of the museums of Paris combined. And that's probably still true, because of course in your kitchen you have genetically modified foods, you have a computer chip in almost every device in the kitchen, whereas in the Dallas Museum of Art, there aren't all that many computer chips. So indeed, he was an advocate for artists appropriating the landscapes made visible by science, but it's also appropriating the tools of technology for purposes of artistic expression. He started having exhibitions, and he couldn't get the art critics to write about his work. So he got upset, so he set up an art journal where he could write about his own work, and other artists could write about their own work. It was founded in 1966, basically to document the work of artists involved in science or artists involved in technology. And at the time, it was not obvious. The art world was on a very different track, abstract expressionism and all kinds of other interesting art movements. And so he was definitely an outsider in the art world at the time. He did it as a peer-reviewed journal, which is also unusual in the art world, because typically editors in the art world publish their friends and family first. And so he really felt that he wanted a professional journal where artists and scientists could document their work in collaboration. And so as part of that, when he died in 1982, I founded two nonprofit organizations called the Leonardo Organizations, one in Paris and one in San Francisco, basically to network these creative communities. And as Rachel said, one of the joys of my life has been a networking node between people who are often no more than one building from each other in the same institution, but often find it difficult to actually find ways to collaborate. And it's been one of the great pleasures of my professional life, building these professional communities. Ironically, for many years I worked as an astronomer by day, in the art world by night, which is sort of backwards, but anyway. So the combination of the arts and sciences has always happened, of course. You're all familiar with the stories about Leonardo da Vinci and so on, or Goethe in the 19th century. But so what's new? Well, I think there are two interesting things going on at the moment that are very exciting developments. I'm calling them the new hybrids. Now, of course, Samuel Morse, inventor of the Morse code, was also a very successful portrait and landscape painter. So there's a very long history of people with such hybrid careers where the same individual is exceptional both in art and science, or technology and art. So this has happened before. And also new forms of collaboration. And I think there are three reasons of why there's an explosion of this kind of work at the moment. First is shared tools. When everybody uses the computer, there's a very subtle effect that happens that you start talking about the world in the same way. In philosophy, you call that shared epistemologies, because indeed you get so used to using the same tools that in fact you end up with a unified view of viewing the world. This of course happened in the Renaissance with the development of perspective, for instance, where both artists and architects, engineers started developing new ways of describing the things they were building and the things they were seeing. But the computer revolution has provided a new common language between artists and scientists that has made it much easier for artists and scientists to work together. In fact, I joke, sometimes I go to an artist studio, and it's better equipped than some of the scientific labs that I visit as I travel. So indeed, artists today are very often technically not only literate, but innovative. The second thing, of course, is the born digital generation. People born since about 1980, it's just part of the way that you live. And of course, any of you that have 3 or 4-year-old kids with their first cell phones know what I'm talking about. Sometimes it just shapes the whole way you think, and being born digital is a transformative situation, which really changes, I think, fundamentally the ability of people who are interested in the arts and interested in the sciences to work together. And so I think that's the second reason that there's been an explosion, not only the shared tools, but people that grow up with their tools, those tools from a very young age, just are used to acting in the world, looking at the world through those kind of tools. And that has been a really exciting development that has changed the situation. And then thirdly, and I'm saying things you all know, but when you're living in the middle of something, it's maybe not so obvious. Scientists live in ghettos. If you try and get into my science lab in France, you need a badge. You need to call the guard at the gate to let you in. Most scientific laboratories are in ghettos. With the networked culture, suddenly people get access to sciences and scientific knowledge without having to go to the gate and the guard. And that has allowed new forms of collaboration that used to be really, really difficult. And so one of the pleasures that I've had in recent years is really enabling artists to have access to scientific knowledge and scientific technology. And with the internet, it's really possible to do collaborations with people that live in totally different social settings, totally different institutions. And so this triad of things has really changed the situation. And so I think we're seeing an explosion of development of what I call the new hybrids and new forms of collaboration. The journal Leonardo, which I've now edited since 1982, since my father founded the journal in 1967, we've published maybe 8,000 or 9,000 authors. If you took those 9,000 people and their close families, that would be a community of 20 or 30,000 people. That's a bigger creative community than fueled the Renaissance in Italy in the Renaissance. So indeed, the creative community of this kind, they're all over the place. And I think this is really changing a lot of the possibilities for connecting the arts and sciences. And that's one of the reasons that at this point in my career, I've decided to spend all of my time working on expanding these possibilities. So I'm going to give you a bit of a sales pitch of what convinced me to go to UT Dallas. And let me tell you, it took them about 3 years to convince me. So they had to wine and dine me all the way up to the presidential level to convince me to move from a nice civil service position in France, where I was looking to nice retirement on the Riviera, to moving to UT Dallas. But let me tell you, it was just too good to turn down, and so they convinced me to take the position. So the Art and Technology program at UT Dallas was founded 6 or 7 years ago by a man called Tom Linehan, who was a student of a pioneer of computer graphics called Chuck Suri. And the Art and Technology program is in the School of Arts and Humanities, which is already unusual. In most universities, the Art and Technology program is in the School of Engineering or Computer Science. That's the natural home for computer art, graphics, and animation. And my appointment there is explicitly to create research links with the School of Natural Science and Mathematics. So that's why I, an astrophysicist, am in the School of Arts and Humanities. And the program has 2 parts to it. One is Art and Technology, and one is Emerging Media and Communications. We now have a BA, MA, MFA, and PhD program that was started in September. So indeed, we can train hybrid professionals all the way from entry level into college to the end of the PhD if they choose to go that route. It's slightly incredible. It's like a startup company, and it's being done Texas style. We have 630 undergraduate majors and 160 graduate students. We're sizing the program for 2,000 students. That's bigger than most art schools on the planet. And we have a new building that opens in a few months. We're beneficiaries of Texas-style private philanthropy. And indeed, my position is one of 3 endowed chairs that we're currently in the process of filling. And so, as I started looking at what was happening in this university, I said, I'm going to give it a try. We have a cluster hire of 9 positions, which these days, if you're in a university, is slightly incredible in any field. That kind of a commitment to an emerging area of research and teaching. There are 2 major areas of research, I would say, and this is my description. One is the whole problem of building and designing virtual humans. That includes teaching gaming, but also gaming technologies applied to other applications than entertainment, all the technologies behind simulation, animation, computer graphics. And as I'll explain to you, some of the premier research work that's now being doing in this program is building very sophisticated virtual humans that you can interact with in different kind of situations. The second area, which I'm particularly interested in, is what I'm going to call here a new systems of representation. As many of you know, we're living in what's called the big data era. We're being flooded with huge volumes of data. As an astronomer, I know this very well. I'll talk about it a little bit more later in the talk. But that means, in fact, there are new techniques being used, the science of complex networks, new techniques in visualization and sonification. And so it's our belief that big data is not just more data, it just changes the way you have to make visual evidence from data, how you convince other scientists of what the content of the data is, how artists can express meaning and sense out of very large data sets. And so these are examples of transdisciplinary research areas where not only people in the arts and humanities, but people in science and engineering are confronting the same technical challenges and conceptual challenges. Examples, Monica Evans, who's one of our gaming professors. She's been applying games to math teaching, algebra and calculus. Received a very large grant from the Bill Gates Foundation, which is to create a virtual high school for teacher training. Right now, they're doing what's called motion capture of 50 students, different genders and ethnic backgrounds. Each virtual character has a different personality. The virtual characters interact with each other, not just with you. And so there's a social community of these virtual humans. There are interactive narratives that draw obviously on literature and the humanities to build scenarios, role-playing situations. And the ambitions of the Bill Gates Foundation is to create ways to really provide teacher training tools that allow you to test teachers and demonstrate their skills in a variety of subjects and environments. Now, this is kind of blue sky research right now. We're a long way away from actually using this in schools, but it's being tested by teachers as I speak. But really interesting to see the interest there is in this and the new possibilities. Marjorie Zilke, who's another professor in the program, works on a system called First Personal Cultural Training, has funding both for medical training of nurses. The purpose of the game is to keep the baby alive. If you misdiagnose the disease, the baby dies. Thank God it's a virtual baby, not a real baby. And so you're able to give nurse practitioners and medical personnel exposure to medical situations they will probably meet only once every 5 years or 20 years in their medical profession, but you can train them very much as you train a pilot in a flight simulator before you put them in the plane. You can train the medical personnel in a medical simulator before you start having them do it on real people. Another big sponsor of this work is the US Army. This is not for war games. It's for cultural training of military personnel to accompany their language training. And they have created simulated communities in Afghanistan, Nigeria, and Philippines, where the characters respond differently depending on their cultural background and context, and where you can expose military personnel to a lot of the complications of dealing with the very different kind of environments that they're going to be visiting. The next faculty member we just hired is Paul Fishwick, who's coming from the University of Florida. And his area is in what's called aesthetic computing. And his ambition, he's a computer scientist, is the application of arts and design to advance the computer sciences. So this is a really ambitious agenda, how to improve computer science using arts and design as some of the methodologies and techniques. And he has a demonstrated history in this area. Next young faculty member we just hired is Max Schisch, who has a PhD in art history, but he's been working the last few years as a postdoc in a scientific research lab of a researcher called Laszlo Barabazi at Northeastern University, who's one of the world's leading experts on analyzing social networks. He gets all the data from cell phone companies to figure out how you can analyze people's behavior from their cell phone habits. And Max has been applying these same techniques in the area of the humanities. And so for me, he's a born digital humanities scholar. I've been teasing him that he's going to be doing the post-digital humanities, because indeed, as he says, any humanities scholar born today has got to be digitally literate. That's just the way it is now. And in fact, Max is so comfortable in both the humanities and the sciences that he has a publishing record in both fields. Finally, Scott Gresham Lancaster just arrived in the program. He's a professor of sound design. And I'm really interested in working with him on sonification of scientific data. Sometimes when you're dealing with very large data sets and trying to navigate through a lot of data, sound can be an interesting way of providing additional cues, additional background, additional indicators. Some people call those technologies of attention. How do you draw someone's attention to something? And sound is a really good mechanism for doing that. So this is just to give you some faces behind these ideas. And these are people who really are hybrids, who intend to work both in the arts and sciences at the same time. And so I like to joke that maybe 20 years from now, we will build virtual avatars. And so when I'm working on a hard problem as a physicist, I'll work with 5 or 6 avatars. I'll give them some of the work to do. They'll report back to me if they made progress on how to design a better telescope, and the other one is working on the camera. And so maybe, and this is maybe in the future, we can imagine actually collaborative teams including both real people and virtual people. So that's a bit of a far-sighted vision, but I think we're beginning to see some of the tools for doing that. Okay, so let me get back to a little bit more detail of why an astrophysicist in particular is in a School of Arts and Humanities. And so I just want to walk you through a few ideas that are motivating me. I started my work in astronomy. People used to study one galaxy at a time or one star at a time. I had even fellow graduate students that did a whole PhD on one galaxy. The latest catalog from the Sloan Survey has 500 million galaxies in the catalog. You can no longer study the galaxies one at a time. And the other thing that's interesting, when I was a graduate student, the professors used to lock their data in their cabinet at night, and only their graduate students had access to it. So data was very private. Well, now you can actually go online and access the Sloan catalog and do your own research, whether you have a PhD or not. Very big change in how science can be done. There's a new telescope right now being built in Hawaii. It will map the whole sky 3 times a night. It has a 1.5 gigapixel camera that's about this size. That data will be pouring into the internet and into the data cloud at phenomenal rates, where in fact they're pushing the state of art on data archiving and data processing. And so it's really a transformative situation in astronomy that this big data revolution has led to a very different situation. And here I'd like to give a quote from a friend of my father's, Daniel Boorstin, who was a historian of technology and also a librarian of Congress. And he just made the very simple observation, and this is already back in 1991, I think, that we have moved from a world of data scarcity to a world of data plenty. We used to be meaning rich and data poor, and now we're data rich and meaning poor. So that's where the humanities fit in. He called that an epistemological inversion, which is a bit of a fancy term for saying the data flood is changing the way we do science, the kinds of science we can do, and it's really a new situation. He always used to talk about, Darwin's problem for the theory of evolution is that he had all these ideas about how the world worked, but he had no data to test it. So he had to take a boat. He had to go around the world to the Galapagos. And he went around sketching stuff, sketching birds and turtles and so on, bringing the data back to England. But if you go to Darwin's home in the south of England, all of his data fits in about 15 notebooks. And with that, he was able to make a convincing theory of evolution that convinced his peers at the time, even though it's not convinced all of our politicians here yet. Today, we're in a very different situation. A lot of science now is not done by taking new data, but it's trying to make sense of the data that we already have. And this is a really interesting situation which gives new opportunities. And indeed, when you start talking about data rich and meaning poor, that's what the arts and humanities are about. How do you create systems of representation, ways of creating sense and meaning in the data flood? Just an example, this is a graph of the amount of data collected by NASA about the planet Earth, beginning in 2004 to 2012, and then it's a projection. And so indeed, the projection is over the next 10 years, the amount of data collected by NASA about the planet Earth is increasing at a huge rate. And one of the interesting things on this graph, for those of you who are experts in these things, the top blue part of these charts is not data about the world, it's simulated data. We're now creating simulations of the world at a quicker rate than we're collecting new data about the world. And of course, if you're in climate change, that's what you do. You spend all your time building more and more complicated simulations about the world. And in fact, those data floods are also increasing more and more quickly. So as data becomes plentiful, it's not just more data, it changed the way that you do science, the kinds of questions you can ask. New kinds of mathematics have to be used. I've mentioned the science of complex networks. New kinds of theories. Suddenly simulations have the status of a theory. That didn't used to be the case 50 years ago. And of course, when you have a data flood, you start doing what's called pattern recognition. You look for trends. Of course, that's what economists do. Where's the economist? And that's not very good in economics, because extrapolating trends in economics is not a very viable way of building a theory. In some fields, it actually is a reliable way of building a theory. So new research questions that can be asked that you couldn't before. I always like to joke, if you're a PhD student in astronomy, you don't study things in the universe that happen once every million years, because your PhD may take a long time. When you have the data flood, suddenly you can start looking at very rare events. And so indeed, you can start asking research questions about things that don't happen very often, but may be really significant. And so it's interesting how the data flood changes some of the emphasis. Of course, new blind spots. They're all kinds of people who analyze the data there is, but maybe it's the wrong data, maybe it's biased data, maybe it's screwed up data. And so one develops new blind spots, which of course any kind of knowledge system does. And then, of course, in the humanities, a huge debate of how you combine qualitative data and quantitative data on some questions where we don't really have the first clue of how to build real clear theories. Take the topic of consciousness, which is a well-established phenomenon, but clearly you're going to have trouble right now just using quantitative data. Some other issues that come up as data becomes plentiful. For the engineers in the crowd, lots of new jobs out there. Obviously, all kinds of new technologies are needed to deal with the increasing flood of data. You can't treat data as objects anymore, but as a fluid, as a data flow. And that means different kinds of software approaches. Immersion in data rather than illustration of data. And then, of course, the other thing that's happened, and I want to talk about that a little bit, is when data becomes public, all kinds of people can start analyzing it. And that's a really interesting situation, which has been led to what's called citizen science movement internationally, where hundreds of thousands of people who are not in universities and not in company R&D labs, often don't have a PhD or an advanced degree, are able to make major scientific discoveries using the data that's now available on the web. And that's really a very new situation. So I just want to emphasize that we're living in the middle of this period. The first explosion was what's called scientific visualization, as computer graphics and computer animation and computer processing started being developed in the 1990s. And that was already transformative. Lots of new professions were developed. But the big data transition that's happening now, field by field, from economics to medicine to the sciences, and also to the arts. If you go to a special effects company in Hollywood, let me tell you, you're in the data flood. You're in the big data era. And so the whole issue of how we go about finding new ways of explaining what's in data to other people, whether it's your peers or the general public, is really a non-trivial matter. When systems of perspective were developed in the Renaissance, nobody had a clue as they were doing that what the way to do it was. Of course, as perspective got established as a system of representation, it shaped a lot of the way we view the world and our place in the world. And so 50 years from now, we'll look back and there'll be people in the arts and humanities and science and engineering developing these new approaches. Okay, so now I'm just going to take another astronomical detour. So astronomy went through the big data transition very early. When I was at UC Berkeley and we were building this NASA satellite, we started confronting some of the issues of big data. And astronomers were some of the first people to really get their hands around the problem, to establish the systems. Now, of course, the major discovery that came out of all that is we discovered that most of the universe is dark. Well, it's kind of embarrassing. You know, astronomy is probably one of the oldest sciences in human society, and we've just been studying the decoration all this time. The universe, 95% of it doesn't emit light. Well, that's bad luck for us human beings that have eyes that see. Most of the universe is dark. It emits no kind of light of any type. It's of an unknown nature. And in our ignorance, we call it dark matter and dark energy, which really helps. Ironically, we have damn good scientific models for the universe. We have really good scientific models. If you look at a picture like this, which is galaxies and gravitationally lensed, in fact, we know where the dark matter is in that picture. We can now map it using various kinds of techniques on how the dark matter distorts the light that's reaching us. And we can make computer simulations of the evolution of the universe all the way from the Big Bang to the present. Beautiful theories, beautiful models, well tested, well confirmed, using the existing data. And so I just want to show you a representation of the history of the universe in 8 seconds. And let me tell you, this model really works. It really fits. This one was made by some German colleagues. So don't blink. I'm going to show you the history of the universe in 8 seconds. Bill Gates willing. So that's the structure of the dark matter in the universe from the Big Bang to the present. It matches everything we know about the universe. We just don't have a clue what it's made out of. We know it exerts gravity. We just don't know what it is. Which means you can get lots of funding proposals from the NSF. Here's a totally different representation of the same simulation. I want you to close your eyes because you're going to listen to the first 100 million years of the universe from that same data. Both equally valid representations of the same data. Do you make sense of that data the same way, visually and sound? No. Is one better than the other? No. Now, of course, if you were in the Renaissance and the system of perspective hadn't been developed yet, you wouldn't know either that the system of perspective was going to be really successful. And so here we are dealing with 95% of the universe of an unknown nature. We can model it very accurately. We can even make beautiful representations, but we don't have a clue of what it's made of and what its physics, internal physics is. So I'm going to overgeneralize a little bit, and I think this is part of a general problem where science doesn't make sense. And by what I mean by that is the things that make sense to us are the things that we grow up with as kids. We know what wood sounds like. We know what plaster sounds like. And so we have an intuitive knowledge of the things that we grow up interacting with. The trouble is most of the universe is made out of other stuff. And most of the things we know about the universe now come through scientific instruments. You've never played with dark matter. You don't know if you take two dark matter balls and knock them together, what happens to them, because there's no way your experience is able to do that. And this is true in the nanosciences, in quantum mechanics, in field after field, where scientists now tell us what the world is made out of, but our bodies and our senses have no way of having contact with that part of the world. So few people have experience with what I'm calling here mediated senses. Every instrument that I've built hallucinates. That is, you occasionally get this funny image and you say, oh, something screwed up. The gain level drifted. Throw that one away. I hallucinate. Actually, I'm a sleepwalker. And occasionally I do something in the middle of the night and I say to my wife, who's that in the corner of the room? And my wife says, go to sleep, Roger. You're sleepwalking. You're sleep dreaming. Fortunately, she and I have the same senses, and so we can test each other's perception of reality. We have nobody to discuss dark matter with. So is my instrument hallucinating? Well, I don't think so. If you build enough instruments that see the same thing, then hopefully that's a good test. So most of the human world is not only unreachable by our senses, but it's not on our scales. And we don't know how to reason about things that aren't on our scale. The internet is connecting millions of people together, and it's exhibiting behaviors that we're only beginning to understand. We have trouble enough understanding how a family works, where we have a lot of direct experience. How do you understand how millions of people interact with each other in a complex network? So you're really dealing with phenomena outside of human experience, and more fundamentally, as the philosophers in the room will tell us, that means that we have the wrong epistemologies and ontologies. We're being trained on the wrong data with the human senses to understand this stuff. And so I think one of the interesting things that artists can do is to help us make things that are not sensual intimate in some way. And so I'm just going to, what time am I supposed to stop? 8:30? Okay. So let me just give you a couple of examples of what I'm calling intimate science here. You've probably heard that climate warming is happening. It's due to something called CO2. Trouble is it doesn't smell and it doesn't taste. So even though the CO2 levels have been rising, we didn't notice it. The first scientific reports on CO2 increasing and its effect on climate was actually in the 1880s. It took 100 years for that signal, that knowledge, to reach the brain of the US president, and not all of them. The trouble is you're dealing with gases that our senses cannot experience directly. So here's a nice little example. This is from an artist, Catherine Marwaki. She works with what I call smart textiles. Normally the textile is white, that's the handbag she built. And then she puts a pollution sensor or a carbon monoxide sensor in the bag. And when the pollution level goes up, the bag turns red. Let me tell you, if you were walking around Los Angeles and everybody's handbag had turned red, you might move. Because suddenly it's not just the smog alert, you suddenly realize that in that neighborhood, the level of pollution is above what's safe for human health. So indeed, here's an example of an artist taking data, in this case pollution data, and making it intimate, and a handbag is about as intimate as you can get, or a t-shirt, you can make t-shirts out of this material. And so indeed, here is an artist who, just like a painter, is collecting data about the world, making sense of it, giving it meaning, in this case, in terms of apparel and fashion. Okay, so the other piece there is a Los Angeles artist, but I assume that you might know her work here, Beatriz da Costa. The work that I'm just showing here that she did is with homing pigeons, racing pigeons in Los Angeles, where she worked with pigeon racing communities. She attached pollution monitors to the back of the pigeons. And so as the pigeons went out and then came back, at the end of the day, the data was collected, and she was able to look at the variations of pollution level in the LA basin block to block at the height that pigeons fly. And let me tell you, it's horrifying, because what the radio tells you is the average level, but depending on the block you're in, which the exact topology of the ground, there are factors of 100 variation in pollution levels. And so indeed, just like Paul Cézanne was out there painting his mountain, she's out there painting the pollution map of Los Angeles as an artistic work. Very social activity, obviously working with a pigeon racing community. And there are now thousands of examples of artists doing this, collecting data, which would be normally called scientific data, but using it for artistic purposes. And I think this is a really important function. It's part of the making sense, making meaning of data flows. And I'm very excited about encouraging artists to do that. I just wrote an editorial about 3 months ago on a new Sublime in art and science. So I'm a scientist, I'm a positivist. I think the world exists whether I exist or not. I'm also an atheist. I don't think there's an external driver on the system. On the other hand, I've just told you that as an astronomer, I have to admit that after 100,000 years of astronomy, 95% of the universe is made out of something that is dark, that we astronomers don't know how to study yet, and it may take another century. So this kind of happened in the 19th century. There was a lot of discussion about the sublime. What happens when you get to the edge of something that you know, and there's that huge fear of what's beyond it? And indeed, in my discussions with humanities scholars, I said, well, what if human beings were so badly designed that it's just not going to be possible to understand the universe? Now, most scientists would resist that idea totally, right? And fortunately, there are some anthropologists here who've been studying what scientists do. But what if? Maybe there are things that are just untranslatable into human cognition. That's kind of unsettling for artists. We're kind of used to things that are unknowable in science. So the inside of a black hole is unknowable. You can put anything you want in a black hole, and you will never know what happened to it, what topology it took, what shape it took. So scientists are kind of comfortable with certain things being unknowable in science. Historians of science have talked about things being incommensurable, which is you can have different descriptions of the world, but they just don't match. And what about if it's incomprehensible? So, I have the confidence of a scientist that can give me a bit more funding and we'll figure it out. But maybe there are some deeper questions that underlying all of this. And it's certainly, for a scientist, it's really frightening to think that maybe certain things are incomprehensible because of the way human beings are built. So do we need to design, I'll come back to my virtual humans with other senses. Maybe to understand the world, we need to collaborate with other beings that are designed in a different way. I mean, after all, evolution functioned on the evolution of humans, basically so I can get out of the room when I finished giving my lecture. I just had dinner, so you've got to be able to find the food on your plate and to procreate. And so the human sensory apparatus was adapted for a very minimum set of requirements. None of those requirements had to do with understanding the world and how it functions. And so I think it's an interesting long-term question whether we're at a new Sublime in the same way that, and we forget, at the end of the 19th century, people really had their minds blown when electromagnetism was discovered, and people discovered you could communicate with people at a distance using telegraphy. I mean, let me tell you, it's pretty frightening for people in the 19th century when suddenly they realized that there were all these forms of energy that people had been totally ignorant of before. So maybe at the beginning of this new century, we're in a similar situation. So I'm just going to try and wrap up with a slightly more institutional remarks on this. Over the past 15 years, funding agencies have been getting proposals from schools of art and design and schools of arts and humanities that look indistinguishable from proposals from schools in science and engineering. And that's part of what I've told you, this new phenomenon of the new hybrid professionals and the new forms of collaboration. And sometimes the content is totally undistinguishable, but the NSF doesn't know how to fund artists. That's just not part of their mission statement. So what's going on? So in 2001, the first report was commissioned, and the feeling was at that time it was really focused on the computer sciences. It was the computer revolution that was leading to the computer arts, computer graphics, and animation that led to what was going on, and as I referred to, the first wave of scientific visualization in the 1990s. The other thing that was going on was the emergence of new industries, often called the creative industries. As you know, the gaming industry right now is one of the biggest industries internationally. Their R&D budget is actually larger, I think, than most government R&D budgets at the moment. So they funded a National Academy of Science report, which was called Beyond Productivity, and it led to new funding mechanisms to fund artists and scientists working together around computer sciences. Well, what's happened in the last, and it's no more than the last 10 years, artists have been invading other areas of science. And Rachel, my area, is a good example with primatologists. But indeed, art and biologists, there are artists now using genetic engineering technologies in the environmental sciences and the medical sciences, And an example of the kind of thing that's happening is the artist Diane Gromela, who's just established a scientific institute for the study of chronic pain, and she has an MFA. So indeed, we're beginning to see in other areas of science and engineering, artists playing leading roles in developing new research agendas. So what's been happening over the past 2.5 years, is the National Science Foundation and the NEA have been convening this community to try and figure out what's going on. The NEA has also been developing programs with the National Institute of Health, because so many artists are becoming involved in the health sciences, and there is there's serious interest at the NSF. As part of this, the NSF funded a network for science, engineering, art, and design at the end of last year. I'm leading a committee that's developing a report that we have to submit next summer, basically looking at what's happening and making recommendations of what might be needed in the future. An interesting part of this has been what's called the STEM to STEAM movement. Many of you, since this is an engineering dominant school, know about the STEM education crisis in this country. I think the presidential candidates say there are 800,000 high-tech jobs in this country that are unfilled. We just can't find enough American applicants to do that. That's the same in many European countries. And so indeed, for whatever set of reasons, STEM careers are not attracting enough young people. The STEM to STEAM movement has really been shaped by John Maida, who's the president of the Rhode Island School of Design, and there's actually now a bill in Congress which has 3 signatures. So if you know any congressmen, we need more signatures, which is basically of integrating the arts and humanities into STEM. And let me tell you, in our case, we have an art and technology program. The students may be coming in to learn gaming, but they have to take programming, they have to take data analysis, they have to take data visualization, and they come out of our programs, and most of them are ending up in careers that are really STEM careers. So indeed, they may be graphic artists, they may be animators, but they also have to have, under the hood of their skills, many science and technical skills that are required for these new forms of arts and entertainment. And as part of that, to enable pathways for the hybrid careers that I've been talking about. So I'm going to wrap up with a last couple of slides. So I know there are a bunch of scientists and engineers. We had a little bit of a discussion at dinner this evening about, in the good old days, physics was the queen of the sciences, and the presidential science advisor was always a physicist. That's not the case anymore. A famous report in the history of science institutions was written by Vannevar Bush in 1945, called Science: The Endless Frontier. And it's really spooky reading that report. New frontiers of the mind are before us. If they are pioneered with the same vision, boldness, and drive with which we have waged this war, we can create a fuller and more fruitful employment and a fuller and more fruitful life. There's probably not more than 1% of the world population that believes that, and certainly listening to the American political campaign, there's maybe not all of the politicians in this country that believe that. So it used to be that scientists were very confident that by investing in science and technology, we would lead to a full employment economy. It didn't happen. All kinds of other things happened. And in fact, common science doesn't make the kind of political sense that it used to make. I was at a talk from Alan Leshner, the president of the American Association for the Advancement of Science, in January. He had just come out of the congressional budget battles, and they were losing all the arguments they used to win. And he said politely, the link between science and the rest of society is a little fragile these days. The Spanish government has cut science funding by 30%. The Italian government is doing something similar, so they don't believe that to get the Spanish economy out of the economic mess they're in, that science and technology is a key investment. Leshner said, "We must engage with the public on the issues and seek common ground. Science is now encroaching on values so much that the consensus no longer exists." And we know what we're talking about in this country, and when I'm in Texas, I even know that even more. Science is in collision in place after place about the common values that people have that are not shared by the scientific establishment. And it's not as easy as pointing the finger at the people who don't get it. He talked about the integrity of the scientific enterprise. There's always a few bad apples in any organization. The level of scientific fraud has been going up dramatically internationally. Papers are getting withdrawn from scientific journals because scientists make up their data. This used to be something you could ignore, but all the debate around the climate change science is indicative of how delicate the question of trust is in science as an enterprise. And then he talked about the need for public engagement and the setting of priorities. And it used to be the presidential science advisor used to work with the scientific community and set the national priorities. It's just not going to work that anymore. In Europe, the Helga Novotny, who's the president of the European Research Council, puts it this way: society is moving into a position where it's increasingly able to communicate its wishes, desires, and fears to science. She calls about the call for a socially robust science. So I think, and I'm afraid, that one of the reasons that we need to find ways for the arts and humanities to work with science and engineering is because science itself is in trouble and needs socially re-embedding. Thank you for inviting me.